We will be discussing the problems from JEE Advanced. Not all the problems, some of the problems that were my favorites from the question paper. I do not have the team, neither the time to discuss all of them. So I'll be taking my favorites. And if you have any more doubt, you can always ask me in the comment section. So the first question is from the House of Solutions of Triangles, and the problem reads as: consider an obtuse angled triangle ABC in which the difference between the largest and the smallest angle is pi by 2 and whose sides are in arithmetic progression. Suppose that the vertices of this triangle lie on a circle of radius 1. Now we have two problems. In one we have to find the area, and in the other we have to find the end radius. Now this was a problem which was based on sine law and cosine law. Sine and cosine law. So we have some equations. Let's make them. We consider this obtuse angled triangle. I don't know when my drawing will improve, but I hope it will improve fast. It will improve soon. So let us say this is the obtuse angle triangle ABC. This side means B, this side means A, this side means C. So we assume that A greater than B greater than C. Okay, you can assume any of the two here, and obviously the side opposite to the obtuse angle will be the largest, and we have A minus C equal to pi by 2, since he has said that the difference between the largest and the smallest angle is pi by 2. Then we have that the sides are in AP, so we have 2B equal to A plus C. The sides are in AP. Since the order of the AP in increasing sequence will be C, B, A. Right? C, B, A. So 2B equal to A plus C. Now we will have some more equations. See, one equation will be A by sine A will be equal to B by sine B equal to C by sine C, and these all will be equal to 2 times R, which is equal to 2. Since the circumradius, they have said that all the vertices of the triangle lie on a circle of radius 1. So this means the circumradius is 1. So now we have these equations to solve. So let's start solving. From the first equation, A minus C equal to pi by 2, we send C to the other side. A is equal to pi by 2 plus C, and take sine on both the sides. So sine A is equal to cos C. Now, uh, put in this sine A is equal to cos C. We'll use it. See how. We have sine A is equal to A by 2. And we have cos C equal to C by 2. Sorry, sin C equal to C by 2. And we also know that sin A is equal to cos C. So if I square and add, then I should get A square plus C square upon 4 is equal to sin square C plus cos square C, which is nothing but 1. So we have a square plus c square equal to 4. Now we have the equation 2b equal to a plus c. So now we have 4b square equal to 4 plus 2ac. So we get ac equal to 2b square minus 2. Okay. Remember we have to find the area of the triangle. Okay. So let us write that down also what that expression will be. The area of the triangle is given by ABC upon 4R. Since we know that R is equal to ABC by 4 delta. So now we will have these relations. In this question is denoting area by A. So let's keep it as A. Okay. So area is given by, let it be delta only because I have used capital A. Okay. So it does not look good, right? So delta or the area of triangle is given by ABC upon 4R. Okay, so I have the value of AC in terms of B. I have this capital R. So now the only thing needed to find is B. And that should be pretty easy because if I see, I have the cosine law. So I can write cos B equal to, even without looking at the figure, A square plus C square minus B square upon 2AC. So we have the value of cos B, which is equal to A square plus C square is 4 minus B square upon 2 times AC. So 2AC is equal to 4B square minus 4. 2AC is 4B square minus 4. Just put 2AC here. And this cos B, how to obtain cos B? We have sin B is equal to 2B by 2. Okay. We have this can be written as under root 1 minus sine square B. And we have B by sine B equal to 2. So this implies sine B equal to B by 2. So now plug this in to this equation and we have under root of 1 minus B square by 4, that is equal to 4 minus B square upon 4B square minus 4. So we have 4B square minus 4 by 2 equal to under root of 4 minus B square. So we have 2B square minus 2 equal to root of 4 minus B square. And now taking square on both the sides, we will get 4B to the power 4 minus 8B square plus 4. This is equal to 4 minus B square. So we have the value of B as root 7 by 2. B is equal to root 7 by 2. So now the area of triangle is not a big task. Area of the triangle is root 7 by 2 times AC, which was equal to 2b square minus 2. So 2 times 7 by 4 minus 2 divided by 2r. 4r. So 4 into 1. So this is equal to root 7. This is equal to root of 7 into 7 by 2 minus 2, that is equal to 3 by 16. So delta equal to 3 by 16, and we have to find 64 delta. Sorry, 2 by 8, I guess. Right? Root 7 into 3 by this calculation will lead to root 7 into 3 by 4. Yeah. Root 7 into 3 by 4. So this 64 delta square becomes 64 into 7 into 3 by 16. 64 into 7 into 3 by 64 into 7 into 9. This will be a 2, not 4. Yeah, I have done the calculations in my notebook. So this will become by 4 here. So this becomes 16 into 3 into 7, which is equal to 1008. So this is the answer of the first part, 1008. Now this was a bit lengthy problem, but it was, I think, a doable one. It was an approachable one. It was a theoretical one. Because all you had to do was use the sine law and cosine law and solve some equations. It became lengthier in explaining, but if you will be doing it just for the sake of solving, then it is an easy one, I guess. Now in the this part we had to find the end radius. So for finding the end radius of the circle, r is equal to area by semi-perimeter. So we had find the area to be 3 root 7 by 2, right? 3 root 7 by 2. Area of the triangle was 3 root 7 by 2. And the semi-perimeter is given by a plus b plus c by 2. So this stands out. So we have 3 root 7 upon a plus b plus c. And a plus b plus c is nothing but 3b. Since a plus c was equal to 2b. From the previous slide, see. We had the equation that a plus c equal to 2b. So this becomes 3 root 7 by 3b, that is root 7 by b, and b was equal to root 7 upon root 7 by 2. So we get the end radius to be actually 2 units. So let's do this one first. This one is again from the differential equation only. But the first step is applying Leibniz here. So we will apply Leibniz, differentiate in both sides, and we can differentiate because it is given that f is a differentiable function. So differentiate in both the sides, we have 3fx, and this is equal to fx plus h f dash x minus h square. So we have 2 times fx equal to h f dash h minus h square. And this again reduces to a linear differential equation. हाँ, तो यहाँ से अब अपना ये सोल्यूशन कैसे बन जाएगा? सोल्यूशन अपना ऐसे आ जाएगा, fx into e to the power of minus 2 इंटीग्रल dx by x, वो लीनियर डिफरेंशियल इक्वेशन का फॉर्मूला। ठीक है, ये इंटीग्रेटिंग फैक्टर है बेसिकली आपका, है ना, इसी को इंटीग्रेटिंग फैक्टर बोलते, क्या बोलते थे, इंटीग्रेटिंग फैक्टर। आइए, तो ये बनेगा तुम्हारा एफ एच अपॉन एच स्क्वायर। ठीक है, दिस इज इक्वल टू इंटीग्रेशन ऑफ एच अपॉन एच स्क्वायर डी एक्स। देख लो भाई, हाँ भाई सही है। तो अपने पास आ रहा है एफ एच अपॉन एच स्क्वायर बराबर एल एन एच प्लस टोटल कांस्टेंट सी। अब उसने दिया हुआ है कि एफ ऑफ वन की वैल्यू 1/3 है, तो एच इक्वल टू 1 पुट कर दो। एच सीधा जब 1 पुट कर दोगे तो तुम्हारे पास आएगा एफ एच, एफ ऑफ वन तुम्हारा 1/3, तो 1/3 इक्वल टू सी आ जाएगा। तो अपना एफ ऑफ एच आ गया एच स्क्वायर एल एन एच प्लस सी टाइम्स एच स्क्वायर प्लस 1/3 एच स्क्वायर। तो अब अपन एफ ऑफ ई निकालेंगे, तो एफ ऑफ ई बन जाएगा ई स्क्वायर प्लस ई स्क्वायर बाय 3, दैट इज इक्वल टू 4/3 ई स्क्वायर। तो ये जो है सिंपल सपाट प्रॉब्लम थी। ठीक है, सिंपल प्रॉब्लम थी, एकदम इजी सी थी, और इसमें कैलकुलेशन भी ऐसा सच बहुत हैवी नहीं थी देखी जाए तो, है ना। सो दिस वाज एन इजी प्रॉब्लम आई वुड से। अब कौन सी प्रॉब्लम की जाए, ये तो थोड़ी बहुत की हुई है, सिम मिटाना पड़ेगा। इसमें भी आपके पास x प्लस आयोटा वाई ही डालना था। हाँ, चलो अब नेक्स्ट ये वाली प्रॉब्लम देखते हैं। ये पेपर 1 से है, और एंड this is an algebra problem from complex numbers. Let us see. Let a is equal to 1967 plus 1686 iota sine theta upon 7 minus 3 iota cos theta. If a contains exactly one positive integer n, then the value of n is. तो क्योंकि पॉजिटिव इंटीजर है, इसका मतलब ये जो भी है कि जिस भी थीटा के लिए, लेट अस से थीटा नॉट वो वैल्यू है फॉर विच दिस इज अ पॉजिटिव इंटीजर, तो अपन इमेजिनरी पार्ट ऑफ z 0 कर देंगे, राइट। तो इसे इमेजिनरी पार्ट अपन ने बनाना शुरू किया। So this becomes 1967 plus 1686 iota सिस थीटा टाइप नंबर है ये ना। तो यहाँ पे आएगा cos थीटा प्लस 1686 आयोटा साइन थीटा, फुल स्क्रीन चले जाते हैं। मल्टीप्लाइड बाय 7 plus 3i cos theta divided by अंडर रूट 7 स्क्वायर प्लस 3 स्क्वायर, सॉरी 7 square plus 3 square है ना. अब अपन इस now we will see the imaginary square, imaginary part of this expression. So tell it all the terms which are having a iota in it. So this multiply with this will give us the imaginary number, and this multiplied with this will give us an imaginary number. So we must have that 1967 into 3 cos square theta. It's not 1967 cos theta, it's 1967 only. So 1967 into 3 cos theta, 1967 into 3 cos theta plus 1686 into 7 into sine theta. This should be equal to 0. Since the imaginary part will be this upon 7 square plus 3 square. So we multiply this here and this should be 0. So now we have that tan theta equal to minus of 1967 into 3 upon 1686 into 7. Now we need to do some simplifications. So this becomes 3 5s of 15 and 1 remainder. So 562. This becomes 7 2s of 14. So we get tan theta as minus 1 by 2. So we have sine theta as, now from the triangle we will have sine theta as minus 1 by root 5 and cos theta as 2 by root 5, right? Now plug in this number. So we will have 1967 minus 1686 by root 5 divided by 7 minus 3 into 2 by root 5, that is 6 by root 5. So this is equal to 1967 root 5 minus 1686 upon 7 root 5 minus 6. Now notice one thing, that if this is a positive integer, then we must have that 1967 by 7 and 1686 by 6 are equal. So let us see. And whatever this division will be the answer. So this division here gives 281, right? 281. And this division also here gives 281. So indeed the quotient is same and the answer to this problem is 281. Now how was this problem? For me this was a tough problem, I would say. Like, not conceptual wise, but the magnitude of these numbers, how magnanimous they are, 1967, 1686. So yeah, this was a tough problem, and condensing it down till here, even if you condense it down till here, it is not necessary that you will find the final answer if you are able to observe. If you are not able to observe this thing, that if this is an integer, then these two ratios should be equal. You can prove it using rationalization actually. Okay. If even if you would have carried out the Laurent division, but I just then also you would have been able to solve it. But like reaching till here also, and after that also many might give up, because making this as a positive integer looks really a very challenging task. So this was a tough problem, and it is from the notorious paper 1. Now this is also from the paper 1, but I will be covering it in the next video as this video is becoming long. So see you soon, guys.